Hello grade 12s, welcome to your next rates of reaction lesson. At this point we've covered all of the theory that was completely necessary. So we looked at collision theory initially, and then we looked at the factors that affect the rate of reaction. All that's left to do is actually apply the knowledge. Now when it comes to rates of reactions questions, they are usually based on some sort of experiment. Okay, so usually in a question in an exam you will be given data from a particular type of experiment and then asked to compare the data. And usually it's a little bit of information overload. So what I've done is I've prepared this question. As you can see, this example that I have for you today, I've prepared this example, and the reason why I'm using this is because it provides the data in a way very similar to that of exam questions. In saying so, what I mean is that you usually get this giant table, okay? And this giant table gives us various different experiments. So if you have a look, we have experiment 1 to experiment 6. And then on this side, we have all of the factors that affect actual rates of reaction. So we have the mass of the product, the state of division, concentration, the volume, the temperature, and the gas, also all against time. And what's important about this kind of table is that we take out the relevant information relating to the question that has been asked. Now usually when I get a question like this, I have a look at the table first before I even look at the questions. So when I look at experiment 1, I can see that I've got 0.1 grams in terms of our mass. The state of division, I have grains, so I don't have a block or anything like that, I have grains. I have a concentration of 0.5, the volume is 8, the temperature is 25, and the volume of the gas is 33. At the time that it takes is 140. Now usually I'm going to compare two of these experiments because that will tell me how the rate has changed. So if I have a look at 1 and 2, do you notice that same mass, same state of division, the concentrations are different, the temperature is the same, the volume of gas is the same, but the time changes. So we can see that our dependent variable, all right, is our time, okay, and that we have actually changed our concentration. So our concentration is the variable that we are changing in this particular example. Everything else in this table is a constant. So if you want to compare the rate of reaction for different concentrations, you must keep the state of division and the temperature the same. Does that make sense? Those are controlled variables. If I look at, let's give an example of 2 and 3. If I look at 2 and 3, state of division is the same, concentrations are different, but the temperatures are different as well. And that means that I can't compare experiment 2 and 3 because there are too many variables that are actually changing. Okay. If I look at 1 and 3, I can use that as a means of comparing temperature, because between 1 and 3, I've got 0.5 as the concentration and 0.5 as the concentration. The temperature is 25 for 1, but 30 for number 3, which means comparing 1 and 3 gives me an idea of what will happen to the rate if the temperature is affected. I think you're kind of picking up what I'm putting down in terms of that. I'm now going to look at the actual questions that relate to this kind of table. So the first thing we need to realize is right at the bottom they tell us that the following table shows the results of the reaction between zinc and hydrochloric acid. The total volume of hydrogen gas released is measured. Okay, the reaction time is also measured. Now, for number 1, let's see if I can get question number 1 in on the screen. For question number 1, I'm just going to read it for you first. It says to us that we need to use collision theory to explain why the rate of reaction in 2 is greater than that of the rate of reaction in 1. Okay, now I think you can see the question. Yep. So the rate of reaction in 2 is greater than that of question 1. I know that the rate of reaction is higher because I have 120 seconds over here versus 140. So 2 happened faster than 1. Okay? If I'm going to explain this, I'm going to look at the factor that was changed, which we've already identified as the concentration. And I can see that if I have a concentration of 0.75, then I get a faster rate of reaction than I do if I use a concentration of 0.5. So to answer the question, the concentration in experiment 2 was increased, and that led to greater particles being available for effective collision, hence greater rate of reaction. So we've got increased number of available particles equals an increase in effective collisions and therefore we get an increase in the reaction rate. Okay, does that make sense, grade 12s? Good, just think about it for a minute. The next question, question 2, talks about using the collision theory to explain why the rate of reaction in 3 and 4 is greater than the rate of number 1. So I'm going to compare 3 and 4, okay, with number 1. Those are the 3 that I'm looking at. Now I've identified that all of the concentrations are the same for those 3. 1, 2, 3. You see it's all 0.5. Okay? And I'm using grains for all 3 of them. So that's another variable that's constant. And the only thing that I'm shifting is the temperature. So I have 25 versus 30, all right? Also, and then I have 35. So as you can see, the temperature is increasing from question 1 all the way up to, from experiment 1, and then experiment 3 is 30 and experiment 4 is 35. So the temperature keeps increasing. So if I'm going to use collision theory, I'm going to say the following. I'm going to say that an increase in temperature is going to will increase the number of collisions this will increase the number of effective collisions and therefore my reaction rate will increase. Okay, so those are pretty much the way that we're going to be answering these questions. You can see that it's actually really, really logical. We take the factor that it's changed, okay, and then we link that factor to the reaction rate via the fact that if I'm saying increase in temperature, we're saying there'll be an increase in the number of collisions, okay, which means increase in effective collisions, which means an increase in the reaction rate. What I could also say in between these two steps is I could say that an increase in temperature means the increase in the average kinetic energy of the particles. Okay, we're going to look at question 3 now. All right, so now I'm going to be looking at question 3. And question 3 states, let's just get this all lined up. Question 3 states that we're going to use the collision theory to explain why the rate of the reaction for 5 is greater than that of 1. So we're looking at 5 versus 1 right now. When I look at 5 versus 1, I'm going to look at the following. The mass is the same, so we're fine with the mass. And here is the factor that looks different. So I have grains versus powder. Okay, and that means that the state of division has been increased. We can see that the concentration is the same between the two. The temperature is the same. So that means that all the other factors are being kept constant. I can see, according to my table, that I have 50 seconds as my time for reaction number 5, and then I have 140 for my time for reaction 1, which means that an increase in the state of division, all right, has actually increased the reaction rate because the reaction is happening faster. So when I link this to collision theory, I'm going to say that an increase in the state of division, all right, I'm just going to write division, an increase in the division will give me an increase, all right, in the surface area, which means I have an increase in the likelihood of collisions, all right, increase in collisions. And that, of course, will lead to an increase in effective collisions. Yes? And that means that, therefore, we have an increase in the reaction rate. Okay. So you notice I answer it in exactly the same way as before. Very, very systematically. I take the actual factor that is being changed and I plot out how that factor affects the actual number of collisions and then how that links to the reaction rate. All of these bits and pieces are really, really important. Notice that I have used things like up arrows, all right, while I'm doing the explanation, just for time-wise. But actually, when you do this sort of question, you need to write it all out. Remember, in science, we are totally okay with you using point form. So you do not need to write a whole paragraph. You can simply put these one underneath each other in point form. Okay, we're going to move on to question 4 now. Okay, so question 4 is quite interesting. Question 4 asks us, why does the increased concentration in experiment 2 not affect the volume of the gas produced? Okay, so this is quite an interesting question, and it's one that's asked quite often. The only way we increase the amount of gas is actually if we increase the amount of substance that we are reacting, okay? Because we're going to imagine that everything that we're reacting here is going to run to completion. In other words, my hydrochloric acid is in excess. That means I have enough hydrochloric acid to perform the entire experiment, which means that the stuff that runs out is definitely my zinc. Okay, so as you can see, for experiment 2, although I have a higher concentration, the amount of mass that I start with doesn't change. So the reaction might happen faster, but it's the same amount of gas produced, because that's all we can produce from 0.1 grams of the actual substance. If you have a look at 6, so 6 has way more reactant than the rest of them, and there you can see I have a volume of gas of 42, and that's because I had more reactant to actually react, and hence I created more product. Okay, so this is the way these sorts of questions work. I'm going to send through separately, I'm going to send through the bits and pieces that I would like you to work on at home from your textbook. Please make sure that all of your notes and things are up to date, and I will chat to you again on Wednesday, grade 12s. Have a lovely day.